We're talking about measures of central tendency. That's the big fancy word for this. You guys have probably just heard it as mean, median, and mode, right? You remember that? So mean, median, mode is just taking different ways to take a whole group of numbers, some that might be pretty small, some that might be pretty large, and saying, you tell me about all of them, like what's kind of the middle, what's kind of the central of that, so that we can talk about a set of data as a group. Okay, so measures of central tendency is the words you want to use when you're talking to your parents to make you sound really smart. Right? Mean, median, mode, not as cool. We're also going to talk about range. Do you remember range?
The difference between the smallest and the biggest.
Good. All right, so this should be mainly a review for you. Take a look at the board. We're going to find the mean, median, mode of these values. So right now we're not even talking about any particular value set. We're just, let's throw a bunch of numbers at you that mean nothing. And that's okay for learning purposes. First of all, how do I find the mean? Because that's the type of, all three of those are really a type of average. Mean is the one when I say, hey, here's your average. That's the one we usually use the most. What do I have to do in order to do that?
You add up all the numbers and then divide it by the amount of digits.
Not amount of digits, but amount of
Numbers.
numbers. Yeah. So I'm going to say 46 plus 33 plus 25 plus 21 plus 38 plus 25 plus 30 plus 15 plus 28. And then I divide by, well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I take all of those and divide by 9 because there's a total of 9 numbers. Could I do this longhand and write it all out? Sure. But I think you guys know this well enough where it makes sense to use a calculator with this stuff, right?
It's 190.56111111.
When I add this all up, 190.96.
56. That was divided by 9 too.
Ooh, you're way off then.
Yeah.
You know how I know you're way off? It can't possibly be, you can't have an average there of 190. It's got to be somewhere, like if I look at most of those numbers, they're somewhere like in the 30s, the 20s, the 40s. My average is going to be the middle of those numbers. Might have just plugged something in incorrectly.
I might accidentally hit the multiplication.
Well, that would do it. What'd you get?
29.
29? Okay, now that makes sense to me. If we take this plus 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 this, what did you get a value for that? What was that total value?
29.
No.
Wait, what?
When you added them all up, what was it?
261.
Huh?
261.
261? Okay, so then taking that 261 and divide it by 9, because there's 9 different numbers, gives you an average, a mean value of 29. You say the same thing or not?
I still got it wrong, but is it because I put it in the same thing? Like,
Let me see.
I think I did. I put 28 divided by 9 in the thing. And
Yeah. Because really what you're doing is you added all that stuff up,
And then 28.
and you added, what's 28 divided by 9? About 3. So you just added 3 on the end. Yeah, so press the enter first, and then divide by 9. All right, the other thing is median. Median's a different way to average things. And although I'd say you're almost always going to use mean, there are different times where when you look at a set of data that it might be more valuable or more, I don't want to say accurate, but more meaningful to use one of these other types of central tendency. Median is saying we're going to take all these numbers and we're going to line them up from least to greatest. Right now they're all mixed up. So it looks to me like 15 is my lowest number. Then what do I have? 21. Then 25. I got two 25s. So 25, 25. Then what? 28. 30. 33. 38, and then 46, okay? So the first thing is just put them in order. Median is just the middle. What's the middle number that I have there? If you've got a long list of numbers and you I like to just kind of do this, cross off the first and last, cross off the first and last, cross off the first and last, and so on until you get to that middle number. Now this one works out pretty nicely. It's one number. Why might it not work out so nicely?
Because it could be two numbers.
Correct. So if that does happen, let's say I've got a different list, okay? My list is something like 2, 4, 5, 7, 9, 14. Okay, and I try that same thing. I go cross off the first and last, cross off the first and last, and if I can't cross these off, I have nothing left. So now I do this. This is the weird thing about median. If you get to that point where you have two middle numbers, you actually go back and take the mean, take the average, take the middle number between those two. So here,
Six.
my median would be 6, even though 6 isn't even a number in that data set. That make sense? Kind of goofy there. Okay, and then finally the last one is mode. Do you remember what mode is?
And most often.
Yeah. Which number do you see most often? And in this list, there's only one number that is shown more than once. Which one is it?
25.
Yeah, I got 25 listed twice, therefore 25 is my mode. Okay? Take a look at the next one. You can do this one on your own, I think. Do trucks or convertibles have a greater range of sales? Never mind, I'll do this one with you. The range of sales you listed before, what is range?
The difference between the lowest and the highest.
Okay, so in this example up here, my lowest number was 15, my highest number is 46. What is that range? How much of a difference is there between 46 and 15? I can just take the highest one and subtract away the lowest one, right? Total of? You can do that in your head, can't you?
I'm working on the trucks.
Okay, so this one's got a range of 31, right? Because 15
Oh.
plus another 31 will get me up there. So here, trucks, what's the lowest number?
125.
Okay, so I'm looking at that, and what's the highest one?
560.
560. So the rest of the numbers in between don't really matter to me. I'm just looking for how far do I go to get from the lowest number to the highest number, which is
435.
435 there. And now the question is asking, compare that range to this range. So again, I'm looking for the lowest number, which I think is 600, right?
210.
Highest number there. So yep, the difference between those two. 210. If you were a salesman, and here's where some of this stuff comes into play. If you were a salesman, you're selling cars like this, would you rather have a really large range or a really small range of sales? What do you think?
Wow.
Why? I agree with you. I'd rather have the smaller range. I'd rather have the guy selling the convertibles.
Because you're getting more money.
Well, a smaller range doesn't necessarily mean you're getting more money. He is, right, because he's making more sales. He's talking about 600 and 800 as opposed to the 100 or 400. I think for just planning purposes, like, boy, how much money am I going to bring in this week? You're a lot more consistent if you have a smaller range. Your data set doesn't spread out as much. If you're this guy, he's all over the place. Man, one week he's making tons of money. The next week he feels like he's poor, right? So for a business perspective, it's probably better to have a smaller range of data, or sales in this case. All right, following data shows ages of 20 students graduating from college. I like this guy. Right? He's like, I'm going back to school. I'm getting some extra education. So I graduated from college. How old was I when I graduated from college? 24 or so? I went back for a master's degree, and I got that last year, so I was 37 at the time. So that would skew things a little bit. What we're talking about here, in this case, is not so much the mean, median, or mode or range. We could do that stuff. But we're talking about outliers. The term outliers is really important when you're looking at a set of data, because outliers can kind of goof up your measure of central tendency. So looking at this set of data, besides that guy that's 64-year-old, I already kind of pointed him out, is there another one that just seems out of place?
59.
These two we would consider to be outliers. So a data point that you go, boy, most of the data goes together. That one seems kind of odd, and that one seems kind of odd. It's either way too high, like there in this case, or you could have outliers that are much, much lower than the rest of the data set. Okay, so we just identified those outliers. Now, how do you think they affect the measure of central tendency? Okay, when I say measures of central tendency, again, we're talking about what's the mean, what's the median, what's the mode. Are they gonna affect the mode? Whether they're in there, in that set of data, or not in that set of data, they're not really gonna affect the mode, right? That's probably gonna be the same, it's gonna be one of those 20, I don't know, I see a lot of 22s. I think mode's probably 22. Is it gonna affect the median? If we lined these all up from lowest to highest, would it affect the median? Maybe, but probably just slightly. Okay, so I'm gonna cross that one off. It might affect it, but not that much. Mean, however, it's gonna goof that one up a little bit, isn't it? Okay, because if I don't have 64 and I don't have 59 in there, you could expect the mean to be probably somewhere around 23, 24. But now when I plug in these numbers, now you're suddenly increasing the value of the entire data set altogether. You divide by 2 more, but it's still going to bring that mean up. And you might get go ahead and calculate the mean here. Add them all up, divide by, here, I'll erase this so it's out of your way. I don't know how many are in that data set. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Looks like there's 20 altogether.
Says that.
It says that? Oh, it says it right at the top. I didn't even need to count. See, reading's good too. Math is gooder. What does that mean? You add them all up, divide by 20.
No, I should just put it on my progress.
I got 26.9.
Hang on, where's my clarification?
26.9, huh?
Yeah.
Okay, so now, if that's your mean, if you added all those up, and you're trying to get an average, a measure of central tendency, and trying to find a number that represents the entire group, does that really represent the entire group? That mean value is more than this one, 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 this one. No. It's more than all of those, except for the 2 outliers. Okay, so sometimes what we'll do is take a set of data like this and say, it's not like we're saying that this guy didn't exist, that one didn't exist, but we're saying those don't really represent the in this case, people or the group of data. So sometimes we'll just leave outliers out to get a better picture. And if we left them out and said, let's just add up all of those except for this one, and now we divide by 18, now you'll get a mean value of, like I said, probably 23, 24, and that makes more sense. It better represents the data. Good? Okay. Last thing. Following data shows the annual mean price of regular gas for 10 cities back in 2005. Gas prices are actually right around there now, aren't they? 226, 232, 222, and so on. What's the median price of a gallon of regular gas? Okay, go ahead. Figure out the median gas. I'll do the same thing on the board. I'm going to try to list them in order from lowest to greatest, and I'm going to find the mean, or excuse me, the median. You can do the same thing. We'll race. Ready, set, go.
What? I don't have papers.
Yeah, you should have paper. 231 was the median. And it said the mean, and data shown, the annual mean price. What do we get when we get the mean? Can you add those all up and divide by 10? You get it already? What's our mean here, guys? I'm guessing, just looking at the data, I'm gonna say 234. Am I close?
How many are there?
10.
I got 2.33.
2.33. That's off by a penny. Alright, so now, if the median is 231 and the average mean is 233, you look at that and go, well, that's only a couple pennies, right? It's not that big a deal. But if you're averaging on paying so many gallons of gas per month and 12 months a year, that does kind of add up, so you want to be specific. Which one do you think would be a better measure of central tendency to use?
The mean,
Why?
because that's the average of all the gas combined.
Okay, but so is the median. I mean, like when we say the average, median technically is an average of sorts too. You know, both of those, really, we should be using measure of central tendency, we just use the word average. But why do you say mean is a better representation of this data than median?
Well, I think median because it like shows right in the middle of where it should be.
Okay. I guess I'd look at this and say it kind of depends on, I could agree with both of those. Kind of depends on where you live too. I try not to look, you know, what's this one? Where's that, New York City? Gas is higher? If you're not over there, then maybe mean is the better, or median is the better example, I don't know. So some of these you see a much big drastic difference between mean and median, and it makes more sense one way or the other. But the point of all this is to look at the different ways to represent the data and see which one is the best representation for you to use. Okay? So we're gonna see that a little bit in our assignment for today. Wrong one. I'm gonna have you guys do numbers 10 through 29. Okay, so there's a few extra, I know we tried to stick to 15, I gave you a few extra today, but there's a lot of good review from the last couple of lessons, so you can get started on that now.